Morning all. The topic is working of fog. First of all, we should know what is fog. Fog computing is nothing but the extension of cloud computing. These are the topics we are going to see through this video. How does fog computing works? Why do we need fog computing? Benefits of fog computing, limitation of fog computing, and finally questions. Before we enter into the working of fog, the previous teams already explained about what is fog and architecture of fog. So in this video, we see about working of fog. This is the simple image. We can understand the working of fog. In devices or mobile phones, PC, and things like vehicles. And top we have cloud services. So in between we have fog computing. How does fog computing works? Fog computing works by deploying fog nodes throughout a network. Devices from controllers, switches, routers, and video cameras can act as fog nodes. These fog nodes can be deployed in target areas such as our office floor or within a vehicle, as we see in the previous image. When an IoT device generates data, this can be analyzed via one of these nodes without having to be sent all the way back to the cloud. The main difference between cloud computing and fog computing is that the former provides centralized access to resources, whereas the latter provides a decentralized local area. These are the steps transporting data through fog computing. First, signals from IoT devices are wired to an automation controller, which then execute a control system program to automate the device. Second, the control system program sends data through to an OPC server or protocol gateway. Here OPC stands for Open Platform Communication. We all know about protocol gateway. The third one is the data is then converted into a protocol that can be more easily understood by internet-based services like HTTP or MQTT. HTTP stands for Hypertext Transfer Protocol and MQTT stands for Message Querying Telemetry Transport. Finally, the data is sent to a fog node or IoT gateway, which collect the data for further analysis. This will filter the data and in some cases save it to hard over to the cloud later. Why do we need fog computing? Whether fog computing would help your enterprise depends on your unique circumstance. Generally speaking, fog computing is best for organization that need to analyze or react to data in less than a second. Fog computing ability to minimize latency makes it perfect for the task. We have listed some of the key industries where fog computing platform will further below. Fog computing is finding by its decentralization for computing resources and locating these resources closer to data protecting sources. Processing data close to the edge leads to decrease latency and a reduction in the amount of computing resources used. Fog computing platforms like Starkpath can be used to install an MQTT broker on the edge and send low latency data to it. MQTT means, as I said before, message querying telemetry transport. Here we need fog computing because basically if you are in an industry such as transportation where you need to collect data at the edge of your network, for example we can say vehicles, then fog computing provides you with a rapid and effective way to do this. Fog computing allows you to generate real-time data and insights at the edge of the network without sending information all the way back to the center. These are the advantages of fog computing. There are a number of reasons why fog computing has been deployed. Decreased latency, which means one of biggest advantages of fog computing is reduced latency. Second, flexibility. Flexibility means reliable or flexible of amount of data, reduced performance requirements, widespread geographical distribution, and finally real-time analytics. Decreased latency is the first advantage. Data does not need to be sent to the cloud in order to proceed, and sidestepping this problem makes analyzing and processing data much more efficient, whereas this latency may not be a problem for some applications. If it is used for vehicle-to-vehicle communication system, it can become a matter of life and death. So it's a big advantage. Second, flexibility is one of the principal reasons why fog computing is beneficial is the amount of flexibility it affords organization. An enterprise can have a developer create a fog application before deploying it. And the third one is reduce performance requirements. We should reduce the performance based on the requirements of the device or the data. By not sending data to the cloud, we can also reduce the amount of bandwidth needed that would be otherwise used to communicate the sensors and the cloud. This method would lead to poorer performance than avoiding the cloud, as is done with the fog computing. The fourth one is widespread geographical distribution. Given that fog computing is a decentralized form of networking, it offers a wider range of geographical distribution than traditional networking or cloud computing. This results in a better quality of service for the end user. As we saw in the diagram, the end users are mobile phones, PC, vehicles such as. And finally is real-time analytics. In many environments, the ability to analyze data in real time is of permanent importance. Eliminating the inefficiency and latency that comes with cloud services means that the user can receive genuine real-time analytics. And let's move to the limitations of fog computing. Where there is advantage, there should be disadvantage. That is called limitations. These are the three limitations. The first one is physical location. The second is security. The final one is complexity. We see one by one. Physical location. Perhaps the most significant limitations of fog computing is that is much more geographically restrictive than a cloud service. A cloud service can be accessed from anywhere, whereas fog computing is used to interact with devices on a local level. It does not have any centralized access, which means no permissions at all. Security. Fog computing relies on trusting those close to the edge of the network and the fog nodes to maintain them and protect them against malicious entities. The lack of visibility of these systems due to their physical location can leave enterprise open to external threats. The final one is complexity. If you are using a network with traditional infrastructure, cloud service and fog computing, things can get very complex very quickly. All of this architecture need to be maintained, and adding a patchwork of these complex technologies together makes this a very difficult task. As we said, the limitations of fog computing, physical location, security, and final complexity. Of course, even though fog computing is a valuable technology, it does have a number of significant disadvantages. Those are called physical location, security, and finally complexity. Finally, we move to the questions. There are 3 questions. The type is MCQ. The first one is, dash computing is the extension of cloud computing. From the beginning I said fog computing is the extension of cloud computing. For example, fog computing refers to extending cloud computing to the edge of an enterprise network. Fog computing facilitates the operation of computer or storage and network services between any device and computing data centers. The second question is, fog computing can be perceived in dash dash. Absolutely, the answer is big data and cloud systems. Explanation: fog computing can be perceived both in large cloud systems and big data structures, making a reference to the growing difficulties in accessing information objectively. Finally, the third question is, which of the following computing emphasizes proximity to end users? The image itself, we saw that fog computing, because compared to cloud computing, fog computing emphasizes proximity to end user and client objective, dense geographical distribution, and local resource pooling. Thank you.